Project presentation on detailed study and execution work in post-tension slabs by Divya Kamath and Vandana Reddy, Gokaraju Rangaraju Institute of Engineering and Technology from the Department of Civil Engineering. Pre-stressed concrete is basically concrete in which internal stresses of a suitable magnitude and distribution are introduced to resist external loads. The development of early cracks in reinforced concrete due to incompatibility in the strains of steel and concrete was the starting point. The application of permanent compressive stress to a material like concrete, which is in compression but weak in tension, increases the tensile strength of the material. In 1904, Freycinet attempted to introduce permanently acting forces in concrete to resist the elastic forces developed under loads. The idea was later developed under the name pre-stressing. Other advancements like development of vibration techniques for the production of high-strength concrete and the invention of double-acting jack for stressing high-tensile steel wires were significant. Some important terms. Tendons. A stretched element used in a concrete member of structure to impart pre-stress to the concrete. Generally, high tensile steel wires, bars, cables or strands are used as tendons. Anchorage. A device generally used to enable the tendon to impart and maintain pre-stress in the concrete. Partial pre-stressing. The degree of pre-stress applied to the concrete in which tensile stresses to a limited degree are permitted in concrete under working loads. Transfer. This stage corresponding to the transfer of pre-stress to concrete. For post-tension members, it takes place after the completion of tensioning process. Supplementary or untensioned reinforcement. It is the reinforcement in the pre-stressed members not tensioned with respect to the surrounding concrete before the application of loads. These are generally used in partially stressed members. Transmission length. It is the length of bond anchorage of pre-stressing wire from the end of the pre-tensioned member to the point of full steel stress. Cracking load. The load on the structural element corresponding to the first visible crack. Creep in concrete. Progressive increase in the elastic deformation of concrete under sustained stress component. Shrinkage of concrete. Contraction of concrete on drying. Relaxation in steel. Decrease of stress in steel at constant strain. Proof stress. The tensile stress in steel which produces a residual strain of 0.2% of the original gauge length on unloading. Creep coefficient. The ratio of total creep strain to elastic strain in concrete. Cape cable. A short curved tendon arranged at the interior supports of a continuous beam. The anchors are the compression zone. Cable is the curved portion is in the tensile zone. Types. Pre-tensioning. The method of pre-stressing concrete in which the tendons are tensioned before the concrete is placed is called pre-tensioning. In this method, the pre-stress is imparted to the concrete by bond between steel and concrete. The concrete is cast around already tensioned tendons. Pre-tensioned elements are mostly balcony elements, lintels, floor slabs, beams or foundation piles. Figure shows the pre-tensioning process. Post-tensioned. The method of pre-stressing concrete by tensioning the tendons against hardened concrete, that is applying the pre-stress after the concrete is poured. In this method, pre-stress is imparted to the concrete by bearing. It is either bonded or unbonded. Post-tension process. Bonded. In this method, the strands are bound tightly together wherein the tendons are placed inside an aluminium duct or HPEV pipe. After concrete pouring and curing, the ducts are subjected to grouting in order to retain the pre-stress, leading to the bonding between the strands. Each strand consists of 7 tendons. Advantages of bonded post-tensioning. Large reduction in traditional reinforcements, tendons can be easily woven, allowing a more efficient design approach. Higher ultimate strength due to bond generated between the strand and concrete. No long-term issues with maintaining the integrity of the anchor end. Unbonded. In this, the tendon or the individual cable have permanent freedom of movement relative to the concrete. To achieve this, each individual tendon is coated with a grease or covered by a plastic sheathing formed in an extrusion process. Advantages. The ability to individually adjust cables based on pore field conditions. Procedure of grouting is eliminated. The ability to de-stress the tendons before attempting the repair work. The main disadvantage over bonded post-tensioning is the fact that a cable can de-stress itself and burst out of the slab if damaged. Applications. The use of pre-stressed concrete has revolutionized the entire building industry. Pre-stressed concrete is ideally suited for long-span bridge construction. A typical twin box girder bridge under construction using the segmentally cast cantilever method. CN Tower, Toronto, Canada. Ganga Bridge, Patna. Materials used in pre-stressing. Materials used in pre-stressing are high-strength concrete and high-tensile steel. Properties of concrete. High strength with low water to cement ratio, durability with low permeability, minimum cement content and proper mixing, compaction and curing. Minimum shrinkage and creep by limiting the cement content. To sustain the high stresses at anchorage regions, to have higher strength in the compression, tension, shear and bond, to have higher stiffness of reduced deflection, to have reduced shrinkage cracks. Compressive strength. The minimum grades of concrete for pre-stressed applications are as follows: 35 megapascals for post-tension members, 40 megapascals for pre-tension members. The maximum grade of concrete is 60 megapascals. High performance concrete. The attributes of high performance concrete are as follows: high strength, minimum shrinkage and creep, high durability, easy to cast, cost effective. Traditionally, high performance concrete implied high strength concrete with higher cement content and low water to cement ratio. But higher cement content leads to autogenous and plastic shrinkage, cracking and thermal cracking. At present, the durability is also given importance along with the strength. Types of high performance concrete. High strength concrete, high workability concrete, self-compacting concrete, reactive powder concrete, high volume fly ash concrete, fiber reinforced concrete. Allowable compressive stresses under direct compression. For direct compression, except in the parts immediately behind the anchorage, the maximum stress is equal to 0.8 times the maximum compressive stress under flexure. Allowable tensile stresses under flexure. Type 1, no tensile stresses. Type 2, 3 Newton per mm square to 4.5 Newton per mm square, and type 3 has hypothetical values. Stress strain curve for compression. The stress versus strain behavior of concrete under uniaxial compression is initially linear, and then on generation of micro cracks the behavior becomes non-linear and inelastic. After the specimen reaches the peak stress, the resisting stress decreases with increase in strain. Stress strain curve of high strength concrete under compression. Stress strain curve for concrete under